Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Xylophone by Flinty, and here are the rules. We have normal Sudoku rules where we need to place the numbers 1 through 9 within mini grids, trademark, and orthogonal cues. That is rows and columns. So the mini grids are the boxes, the 3x3 boxes, or the designated 9-cell regions, as I like to call them. So he's calling them mini grids, and then the orthogonal cues, which are the rows and columns. Interesting. We have killer, where etched zones house unique digits totaling indicated large values. So that means you cannot have repeats within a killer cage, and they must sum up to the value in the upper left-hand corner. So for example, these 7 digits add up to 42, these 3 add up to 17, etc., etc. Interesting. Interesting way of phrasing these rules, but I'm not sure what the reference is. I don't know anything about. I mean, I've played Xylophone before as a kid, but I don't really know anything else about it. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's learn how to Sudoku. Okay, 7 unique digits adding up to 42 has to be 3 through 9 because we don't have repeats, so 7 can't be here, 6 can't be any of these. So we're guaranteed a 7 here, and we're guaranteed a 6. This can't be 6, so 6 in one of these 3 cells. 29, 7 unique digits adding up to 29 have to be 1 through 6, and then 8. Because 1 through 7 adds up to 28. To get to 29, you can only increase one single digit by 1. And if you increase 1 through 6, that will necessarily have a repeat in the cage. So that's why it's 1, 2, 3, 4, 6, 1 through 6, and then 8. So this cannot have 3 here. So 3 is guaranteed to be one of these cells. And we can't have 6, it's not 6 here, 3 here. 6 cannot be in this row, so 6 is guaranteed to be one of these cells. Well, 6 can't be either of these because of 6's in the row in the boxes, so that leaves this as a 6 there. This can't be 2, 4, or 8 because of 2, 4, 8 in the box. This can't be 5 or 8 because of 5, 6, 7, 8 in the box. Interesting. Remaining digits of this right central box are the odd digits, 1, 3, 5, 7, 9. I'm not sure if I should be coloring these. No 3 and 7 here. This is 1, 5, 9 as a triplet, which eliminates 1, 5, 9 in the rest of the box. So this is 3, 7 now as a triplet here. That means this cannot be 1, 5, or 9 remaining in column 9. So this must be 2, 4, or 8 here. Interesting. This is 3, 7 adding up to 10. So the remaining 3 digits must add up to 10 without 3 or 7. Well, the possible combinations of 3 digits, unique digits adding up to 10, would be 1, 2, 7, which is not allowed, 1, 3, 6, which is not allowed, 2, 3, 5, which is not allowed because of the 3, 7 pair already in the box, so it has to be 1, 4, and 5. And this cannot be 5 here, so 5 has to be here. That leaves this as a 1, 4 pair, which eliminates 1 and 4 in the rest of the box. So this is now 2, 3, and 9, We are guaranteed a 3 on this cage, so this cannot be 3 here. This is 2, 9 as a pair, which eliminates 2 and 9 in the rest of the row. So this is guaranteed to be 3 here. No 3 here. We have to have a 2 somewhere in this cage to add up to 29. So this is 2, which means this cannot be 2 here. And we are left with this digit being a 1 or 5, because this is 1, 4, 5 guaranteed here. So that means this has to be the 1 or 5 that's remaining in this cage. So that's 1 or 5 there. Okay. So this is 5, which eliminates 5 here, so that's 1. So this cannot be 1 here. This is 4, 5, 8 as a triplet, which eliminates 4, 5, 8 in the rest of the row. This can't be 5, it's 1. Remaining digits in this lower right-hand box then. So 1 eliminates 1 here. The remaining digits in this box are 1, 3, 7, 9. 7, 9 add up to 17 with just 1. So that's 179, which leaves this as a 3. 3 eliminates 3 here, so it's 7 and 3. That eliminates 7 here. 4 and 8 eliminate 4 and 8 in the rest of the column, so it's 5. No 5 here. Okay, remaining digits in row 6 are 2, 4, 6, 8, 9. No 6 or 8 here because of 6 or 8 in the column. No 6 here because of 6 in the column. Where is 1 in column 1? Can't be here because of 1 in the box. Can't be in this cage because it adds up to 42. Can't be in this row because of 1 in the row, so 1 has to be here. To add up to 17 with 5 digits, it's either 1, 2, 3, 4, 7, or 1, 2, 3, 5, 6. Because you have to increase 2 digits from 1 through 5. Increasing 1 through 3 will give you 3 through 5 if you try to increase them twice. You could increase the 5 twice up to 7, or you could increase both the 4 and 5 up to 5 and 6. So you're guaranteed to have a 1. So one of these is 1. You're guaranteed to have a 2, so this can't be 2, so one of these is 2. You are also guaranteed to have a 3. So this is 1 through 7 here. No 2, 4 here, no 2, 4 here, no 1 here because of 1 in the box. To add up to 17, it's either you cannot have both 1 and 2 in that cage, and we don't have 1 and 2 available in the rest of this box, so this is going to be 1 or 2, and the other one must add up to 17 with 2 unique digits. If you have 1, it must be 7 and 9, and 1 cannot be here. If it's 2, it's 6 and 9 or 7 and 8. Which means we are guaranteed in this box 3 or 4 in the 42 cage. That eliminates 3 and 4 in the rest of the cage. So this has to be 2. So we are guaranteed 1 or 2 in rows 2 and 3 in this upper left-hand box, and also in rows 2 and 3 in this upper central box. Where is 2 then in row 1? Because it cannot be here because of the 2 guaranteed here, can't be here because of the 2 guaranteed here, also this being 1, that means 2 has to be in this upper right-hand box. It cannot be 2 here, so 2 has to be here. Okay. This can't, none of 5 or 7 can be here. And this can't be 5. Let's see. We do not have a 2 available in this 18 cage. But does that tell us anything? Not really. We could have 3, 4, 5, 6. Remaining digit. Okay, so one of these is 2, so this cannot be 2 here. This can't be 2. It's 9, which makes that 2. That eliminates 2 in the rest of the column. Where is 2 in column 6? Can't be here because we're guaranteed a 2 in this 17 cage. Can't be here because of 2 in the row, so 2 has to be here, which leaves the remaining digits as 6 through 9. Interesting. You cannot have 8 and 9 here. This is at minimum here 1 and 4, which is 5. That means this has to be at maximum 13. Well, that means the minimum here is 13, so the maximum matches the minimum, so this must be 6 and 7, which eliminates 6, 7 in the rest of the column. Therefore, this is the minimum of 1 and 4 here, which eliminates 1 and 4 in the rest of the column. So this cannot be 1 here. This is 7, 9 as a pair, which eliminates 7, 9 in the rest of the column. This 4, 1, 4 pair eliminates 4 here. So that's 8. This is 4. 7, 9 as a pair eliminates 9 here, so that's 1. 1, 4 as a pair eliminates 4 here, so that's an 8, which means none of these can be 8 here. This 6, 7 pair eliminates 6 and 7 in the rest of the box. So this is 3, 4, and 5 here. This cannot be 5 in the rest of the cage. Where is 1 in this 8, 9 pair eliminates 8 and 9 in the rest of the row. So there's no 8, 9 here. Where is 1 in row 1? It cannot be here. So it must be here. So that's 1, which leaves the remaining digits in, actually the remaining digit here as a 5 in column 7. Remaining digits in column 8 as 6 and 9. 6 and 7 eliminates 6 here. 3 eliminates 3 being here. And this 1 eliminates 1 in the box. So this is 2 and 3 or 2 and 4. Where is 1 in this cage, which we need? It has to be here. Nine eliminates 9 here and 9 here. So this is 8. So we have 8 here. This is 9 here. 8 cannot appear in the rest of this cage. So 8 has to be in this 17 cage. And you cannot have 1, 8, and 8 add up to 17 because that would be repeats. So 8 has to be here, and it must be with 2. So it must be 2, 7, 8 adding up to 17, which means this can't be 2, it's 1, which means it can't be 1, it's 4 and 1. 4 eliminates 4 here, so that's 2. So no 2 here. This can't be 3 or 4 because of 3 or 4 in the row. This can't be 5 because of 5 in the row. We have a 3, 4, 6 triplet in this upper left-hand box that eliminates 3, 4, 6 in the rest of the box. So no 3, 4, and this 2, 7 pair eliminates 2 and 7 in the rest of the box. So this is 5, 9 as a pair, which forces this to be 7. So this cannot be 1, 2, 3, 4, 7. It must be 1, 2, 3, 5, 6. So this is 3, and this is 5 and 6. 5, 6 eliminates 5 and 6 in the rest of the row. No 5 here. That's 9 and 5. 9 eliminates 9 here, so that's 8. That means this can't be 8 anymore here. 5 and 6 eliminates 5 and 6 in the rest of the box. That leaves these digits as 4 and 5 in this upper central box. And this can't be 4 because of 4 in the row. So this is 5. That's 4. 5 eliminates 5 here, so it's 9 and 5. 9 eliminates 9 here, so it's 6 and 9. 6 eliminates 6 here, so it's 7 and 6. 4 eliminates 4 here, so that's 9, which means this is 2, 4, and 8. 8 eliminates 8 here. We have 4 and 6 remaining in column 4, but this can't be 6 because of 6 in the row. So that's 4, that's 6. Remaining digit in row 4 is a 3. Remaining digit in column 5 is a 7. That leaves us a 3-9 pair in row 5. So this adds up to 23. If it's 2 and 4, this is 8 and 9. 1 eliminates 1 here, so that's 4, which makes that 1. Remaining digits in row... Where is 7? 7 eliminates 7 here, so that's 9, that's 7. Remaining digits in row 7, then, are 3, 8, and 9. Can this ever be 8? 8 would force this to be 3 and 9, because you don't have repeats in cages. So if you have an 8 here, well, okay, we know 9 has to be here. So then this would be 3, 8 here, this is 3 and 9. 3, 8, and 9 already add up to 20. 20 plus 2 is 22. 20 plus 4 is 24, but that neither of which add up to 23. So this cannot be 8, which means 8 has to be here, which makes that 3. This is not 3, this is 8, 9 as a pair. 3 eliminates 3 in the rest of the column, so that's 4. No 4 here. 7 eliminates 7 here, so that's 2 and 7. 2 eliminates 2 here, so it's 4 and 2. Remaining digit in column 1 is a 2. We have 4 and 5 remaining, and this can't be 4 because of 4 in the column, so it's 5 and 4. 5 eliminates 5 here, so it's 6 and 5. 6 eliminates 6 here, so it's 3 and 6. 3 eliminates 3 here, so it's 9 and 3, which makes this 8 and 9. Good job, you. Thank you. I'm not sure what the reference of xylophone is to any of these. I don't even know how this works as a xylophone for these parts, but anyways. I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.